Let's take a look at some elementary matrices. Here we have a 13 by 13 elementary matrix, which is obtained by interchanging the 4th and the 11th rows of the 13 by 13 identity matrix. Notice that this is a type 1 elementary matrix. Another one. Here is a 10 by 10 elementary matrix. It is obtained by multiplying the 5th row of I by 2 over 7. Notice that this is a type 2 elementary matrix. One more. Here is another 10 by 10 elementary matrix. This one is a type 3 elementary matrix, and it is obtained by multiplying the 9th row of I by -3 and adding it to its 3rd row. Now, if we were asked to describe our first elementary matrix, if we were to write it down, it would take some time to do so because this is a 13 by 13 matrix. So we would need to write 169 entries to describe it explicitly. Or we could do it in a simpler manner. How about we describe it as follows? It is the 13 by 13 elementary matrix obtained by interchanging the 4th and 11th rows of I. This notation does the job. This is the 13 by 13 elementary matrix obtained by interchanging the 4th and 11th rows of I. In our second example, if we want to describe our second elementary matrix, we can say that it is the 10 by 10 elementary matrix obtained by multiplying the 5th row of I by 2/7. If we were asked to describe our third elementary matrix, we would say that it is the 10 by 10 elementary matrix obtained by multiplying the 9th row of I by -3 and adding it to its 3rd row. So let's make the observation. This notation is providing the same information as our first elementary matrix, but more efficiently. This notation, elementary matrix obtained by multiplying the 5th row of I by 2/7, is providing the same information as our second elementary matrix, but it is doing so more efficiently. And finally, this notation, which represents the elementary matrix obtained by multiplying the 9th row of I by -3 and adding it to its 3rd row, is providing the same information as the explicit matrix of our third example, but it is doing so more efficiently. So in summary, we have this notation for our type 1 elementary matrix, this other notation for our type 2 elementary matrix, and this last notation for our type 3 elementary matrix. We will generalize this next. Notation. We use the notation abbreviation of elementary, parentheses, Ri interchange Rj, parentheses, to denote the type 1 elementary matrix obtained by interchanging the ith and jth rows of I. We use the notation abbreviation of elementary parentheses lambda times Ri parentheses, where lambda is not equal to 0, to denote the type 2 elementary matrix obtained by multiplying the ith row of I by lambda not equal to 0. Lastly, we use the notation abbreviation of elementary parentheses Rj plus lambda Ri parentheses to denote the type 3 elementary matrix obtained by multiplying the ith row of the identity by lambda and adding it to its jth row. That's all for now. Thank you for watching.